Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Federated Learning and Privacy. Training AI teams without sharing secrets. Imagine you want to train an amazing AI model, but you're dealing with very sensitive information, like medical records, financial data, or even your personal messages. The traditional way is to collect all this data in one big place. But that creates huge privacy and security risks. Today, we'll learn about a revolutionary approach called federated learning that lets AI learn without anyone seeing your secrets. Traditionally, when you want to train an AI, all the data, from millions of users or devices, is gathered and sent to a central server. Think of it like a giant library where everyone sends their personal diaries. The AI, the reader, then analyzes all these diaries to learn patterns. While effective, this creates a single point of failure. If that central server is hacked, all those private diaries are exposed. For developers, this means a lot of work managing, securing, and anonymizing massive datasets, which is complex and risky. Federated learning flips this model on its head. Instead of bringing all the data to the AI, it brings the AI to the data. Imagine you're a chef, our AI model, trying to learn new recipes. The old way, everyone sends their secret family recipe books to your central kitchen. Federated learning, you, the chef, send out a general cooking technique to different families, devices. Each family practices this technique using their own ingredients and secret recipe book, makes improvements based on their experience, and then sends back only the adjustments they made to the technique, not their secret recipe itself. You combine all these adjustments to create a better, general technique for everyone, without ever seeing anyone's private recipe book. 1. Start small. A central server sends a basic, untrained AI model, our general cooking technique, to many devices, like smartphones, smartwatches, or even hospitals. 2. Local training. Each device takes this model and trains it locally using its own private data, its unique recipe book. The data never leaves the device. 3. Learn and update. After training, the device doesn't send its raw data back. Instead, it calculates, updates, or improvements to the model, essentially how the general technique should be adjusted based on my local experience. 4. Aggregate and average. These updates from hundreds or thousands of devices are sent back to the central server. The server then aggregates, combines and averages these updates to create a new, improved global model. 5. Repeat and refine. This improved model is then sent out to the devices again for another round of local training, making the global model smarter over time, without ever touching your raw data. For a developer, you're designing the initial model, managing the aggregation process, and orchestrating these rounds of updates. As a developer, federated learning opens up new possibilities and challenges. Less direct data handling. You won't directly manage vast amounts of user data on a central server, reducing the burden of data privacy compliance, like GDPR or HIPAA. Focus on distributed systems. Your skills will shift towards building and managing distributed AI systems, where computation happens on many devices. New tools and frameworks. You'll likely work with specialized frameworks like TensorFlow Federated or PySift, which are designed for this type of distributed, private training. Model design for edge devices. You'll need to think about creating efficient models that can run effectively on devices with limited computing power or battery life. Security and aggregation. Understanding how to securely aggregate updates and protect against malicious contributions becomes crucial. Why is this approach so exciting? Ultimate privacy. Asterisk raw data never leaves the user's device. Your secrets stay yours. Enhanced security. Asterisk no central, big basket of data means no single point for a massive data breach. Access to diverse data. It allows AI to train on real-world data from millions of users in their unique environments, leading to more robust and unbiased models. Reduced latency and bandwidth. Asterisk since raw data isn't constantly uploaded, it can reduce network traffic and improve response times for on-device AI. Edge AI enablement. Asterisk powers intelligent features directly on devices, like smart keyboards suggesting words, without constant cloud communication. While powerful, federated learning isn't without its hurdles. Communication overhead. Asterisk sending model updates, even if small, can still be a challenge over slow networks. Device heterogeneity. Asterisk devices have different processing powers, battery lives, and network connections, making uniform training tricky. Data heterogeneity. The data on each device can be very different, which can make it harder for the global model to generalize. Security of updates. Asterisk while raw data is private, the updates themselves can sometimes be reverse engineered or manipulated, requiring advanced privacy techniques like differential privacy. Developer opportunity. Asterisk these challenges are where you come in. Building robust, secure, and efficient federated learning systems is a rapidly growing field with immense potential in healthcare, finance, personalized content, and IoT. Federated learning is more than just a new technique. It's a fundamental shift in how we build and deploy AI, prioritizing privacy and security from the ground up. As you delve deeper into AI for developers, understanding concepts like federated learning will equip you to build the next generation of intelligent, ethical, and privacy-preserving applications. Keep exploring, keep building, and remember, you can train powerful AI without ever needing to peek into anyone's secret recipe book. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.